Why, hello there, lovely ones. So we're going through question 3 of the DBE grade 11 2019 paper. And over here, it's paper 1 obviously. And over here it says, given the linear pattern, blah, 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 determine the general term, Tn, of the linear pattern. Calculate the value of T12, and then which term in the pattern has a value of 130. Now, over here, we have the formula for an arithmetic sequence, which is the same thing as a linear pattern. And in that formula, A is the same value as our first term, and D is the same value as our difference. And with a linear pattern, you'll see that we're increasing by the same amount every time, or decreasing. In other words, we're adding or subtracting the same amount every time. So let's take a look at this. To go from -5 to 0, I am adding 5. And then to go from 0 to 5, guess what? I'm adding 5 again. So the difference between them, let's write 3.1. The difference between each term is 5. It's that easy. The next thing we've got to look at is A. What is the value of the first term? And if we look over there, the value of the first term is -5. So now it's just a matter of substituting it in. Tn is equals to, instead of A, we're going to put -5, and then plus n minus 1 times by D, which is 5, and we're going to multiply out the brackets so that we've got -5 plus 5n minus 5. So just so that you can see where that comes from, it's distributive property. 5 times n gives us 5n, and 5 times -5 gives us -5. So that means our formula for this is going to be Tn is equals to 5n minus 10. The next part of the question asks us to calculate the value of T12. So what that means is, instead of, let's write 3.2, T12, and you'll see that in the formula Tn, the n has been replaced by 12. So that means we are going to go wherever there's an n, we replace it with the value of 12. And minus 10, so that should give us an answer of 50. And that, in English, means that the 12th number in the sequence will have a value of 50. In other words, the sequence would go -5, 0, 5, 10, 15, and it would go all the way up to 50, and this would be the 12th number. The last part of this question asks us which term has the value of 130. So we write 130 is equals to 5n minus 10, and we've got to solve for n, so it's 130 plus 10, which is equals to 5n, and that'll be 140 divided by 5 gives us n, and that of course means that n is equals to 28. Question 4 gives us a number pattern, and it says 13, 27, 45, etc. And 4.1.1 asks us if this is a quadratic number pattern. Now remember, quadratic refers to squares, and here is the formula for a quadratic number pattern. It's an squared plus bn plus c. It asks us to justify whether this is a quadratic number pattern by showing calculations. And so let's do that. The main characteristic of a quadratic number pattern is that you have a constant second difference. So if I'm looking at it, I've got 27 and 45 and 67. First difference between those two is going to be 14. And then between these two, that's going to be 10, so that's going to be 18. And then those two will be 22. And as we can see, there isn't a common first difference, but if we take it to the second level, and that's where second difference comes from, we've got a constant second difference of 4. And that is the defining characteristic of a quadratic number pattern, is that there is a constant second difference of 4. So we would say, or constant second difference at least. Therefore, it is quadratic because it has a constant second difference. 4.1.2 is the reason I put this information over here. It's really important that you learn these formulas off by heart. So a plus b plus c, 3a plus b, and then 2a. And that becomes useful when we need to determine the general term of a quadratic number pattern. All of these are linked to the values that are happening only in this first row over here. So let's just circle it using green. And you'll see also that I've written them underneath each other. And the reason I've done that is because then it's easier for me to show that, and let's do something fancy over here. We're going to take the a plus b plus c and put it to the first one, and then the 3a plus b to the second level, and then the third level is 2a is equals to, and we put it over there. So those formulas you need to know off by heart so that you can use them to calculate the general term. Okay, so I'm going to move this up a little, and this is how I personally would show the calculations. Let's start by writing question number. I would write the three calculations next to each other. A plus b plus c equals 13. Then 3a plus b equals 14, and next to that 2a is equals to 4. And I do that because then I can see which one's the easiest to go first, and this one is the easiest. And we can see that a is going to be 2, and we know that because it's divided by 2 and all of those things. Now if I know what a is, it's going to make the next one easier to solve by substituting a in, or the value of 2 in for a. So I've got 3 times 2 plus b is equals to 14. So b is equals to 14 minus 6, which means b is equals to 8. And now that I've got that information, as well as a being equal to 2, let's substitute both of those in. A is 2 plus b, which is 8, plus c equals 13, so that means c is equals to 13 minus 10, which means c is equals to 3. So the general term for our quadratic number pattern is going to be Tn is equals to an squared, so that's 2n squared, plus bn, so that's 8n, plus c, which is 3. And let's just go back and check. The next question asks us to calculate the value of t100. So that's the 100th term. In other words, let's just write the number. So it's 4.1.3. We're substituting 100 in for the value of n. So you have this amazing thing called a calculator that will do this calculation for you. But because the question is worth 2 marks, it's important to show that you know what you're doing. In other words, writing out the calculation. There we go. The next question, 4.1.4, says the first difference between two consecutive terms of the quadratic number pattern is 110. determine the value of these two terms. Okay, the first difference is going to be the number that's happening in that first line. So it's the first level of differences, and then the second level of differences. This one's a bit complicated. And it's complicated because we've got to try and find the pattern that's happening in that first difference. So I'm just going to move down. And the numbers that we had for that pattern were 14, then it was 18, and it was 22. So we've got to figure out where 110 will be. So let's start by determining the general formula, and we're going to do that by looking for the common difference. This is a linear pattern, and I know that because it's always going to increase by the same amount. Our A value is our first term, and our D value is the difference, which is 4. So A is going to be 14, and plus n minus 1 times by D, which is 4. And remember, this comes from the linear number pattern formula, or arithmetic sequence at least. So like that. And let's simplify. So 14 plus 4n minus 4 will give us 4n plus 10. So we want to know which term number would have a value of 110. So that's the next thing we do. We substitute in 110, and we're going to manipulate things so that we will get 100 is equals to 4n, which of course n is 25. So that means that 110 is going to be the 25th first difference. Let's conceptualize that a little and go back to this over here. So the first difference over here we know was 14, and then we knew it was 18, and then we knew it was 22, and it would have been 26, and then it would have been 30. Okay, and stick with me, this may become a wild run. The first difference was 14, and then term 2, term 3 was 22, term 4 was 26, term 5. Now where that's useful is because in the original number pattern there's term 1, term 2, term 3, term 4, there are lots of number patterns happening here. So if this value 14 falls between term 1 and term 2, that means that 110, which is, what did we say it was? It was the 25th, will fall between the 25th term and the 26th term. So now that we've got those term numbers, let's go back down to where we were. And it's going to be between the 25th and the 26th term. So let's write that in. The first one is the 25th term, and it's going to be 8n, which is that, and plus c. Oh, and c was 3. And then the other one was the 26th term, so 2. And remember that you have a calculator that will calculate this all for us. And as soon as I'm finished writing this, I'm going to do that. And the calculator gave me an answer of 1,453. I've just seen over here that I should have said that this was the 25th term. And the other answer is going to be 1,563. This last bit of this question, and this has gone on for a while, I'm sorry, but anyway, let's read this last bit of this question. It says, show that all the terms of this quadratic number pattern will be odd numbers. There are a variety of different ways we can do that, and I'm only going to do one of them. So 4.1.5, And we know that our formula is Tn is equals to 2 times n squared plus 8n plus 3. Are you ready for the magic? We know that anything squared will give us an even number. But then anything multiplied by 2 will also give us an even number. So this will always have an even number as an answer. Now, if n was 1, let's say, what if it was 1? What is 1 times 8? It's going to be 8. What if n was 3? What is 3 times 8? 24. If n was 7, what's 7 times 8? It's going to give us 56. What you'll see, the pattern over here, is it doesn't matter what n is, it's always going to give us an even number. So even though we don't know what it is, this answer will also always be even. So now we have an even number, and we're adding another even number to it. So just with these two terms combined, we're going to get an even answer. And this is where it gets interesting, because afterwards we add an odd number. And as we know, anything plus an odd number, let's say, any even number plus an odd number is going to give us an odd number. So I chose 52. Let's choose 104 plus 3 gives us 107. And I'm just showing you, or proving to you that any even number plus an odd number will give us an odd number. And that is what you would do over here. You would state that 2n squared will always give an even answer. 8n will always give an even answer. Therefore, all of them will be odd because we are adding an odd number to an even number. Question 4.2 is quite exciting. We've got 4 terms that are given to us. And then we're told that the first difference, the 3 first differences, are those numbers over there. And we're told that this is a quadratic number pattern, and that's why I've set it up already like this. They want us to calculate the values of p, x, and y. Now what we know about a quadratic number pattern is that we have a constant second difference. So let's write that down. The second difference over here is going to be p minus 3, and subtract the first difference, which is 2p minus 4. Then over here, the second difference is going to be p over 2 minus 1, and I'm going to subtract p minus 3. Now this type of question is actually very common, so it's a good idea to pay attention. Now remember, I said quadratic number pattern is characterized by the fact that the second difference are constant, so that must mean that this over here has exactly the same value as that over there. So how do we write that algebraically? It's very easy. We just rewrite it as p minus 3 minus, and then we've got 2p minus 4 is equals to, I know, groundbreaking, and there we go, and minus p minus 3. So now I'm just going to simplify. So just to go through some of the more interesting things that I did, you'll see that I have put minus p over a common denominator of 2 so that I can then subtract them. And then I've done the same thing when rearranging the equations, and of course then I've multiplied both sides by 2, and I've got p is equals to negative 2. Maybe not the most direct way to get there, but it worked. Okay, so now that we have the value of p, we can use it to calculate something that's going on over here. And I'm going to cheat just a little and just copy and paste things. Let's zoom out, and I'll rearrange this by taking this down here. You see? Technology. Okay, so p is equals to negative 2. So the first thing I'm going to do is substitute it into this first one over here. And that'll give me an answer of negative 8. Let's just do something clever underneath it and redraw what's going on. So we had 4, we had x, and we had y, and we had negative 11. But now instead of writing 2 minus p, I'm going to write minus 8. Let's do the same thing with over here, where I've got minus 2, minus 3, so that's going to be minus 5, and I'll put minus 5 over here. And let's do the same over here. It's minus 2 divided by 2 gives me minus 1 gives me minus 2. So now that I've done that, I can see that x is going to be 4 minus 8. So let's write that down algebraically. That, I'll go back to yellow, or red apparently. X is going to be the value of the first term, which is 4. And we do the difference, so therefore it has a value of minus 4. So that's minus 4. Which means that y is going to be the new value of x, which is minus 4, and we're going to subtract 5 from it, minus 5, so that will give y a value of negative 9. And let's just make sure that works by checking. The next difference was negative 2, so negative 9 subtract 2 will give us negative 11. And that means our answers for this particular question was p is equals to negative 2, x is equals to negative 4, and y is equals to negative 9. And that's it from me for today. Much love.